Thank you very much. I'll flick through this very quickly. We've only got 10 minutes and it's obviously a very large topic which could take hours for those who are interested. The SATS program is part of our MindStar autonomous suite of programs and features both hardware and software. And again, I'm flicking through this very quickly and catch up with people later if they'd like to talk through some of these topics. We'll get to the meat of the thing. The Dozer system that we have on offer is a scalable system. It functions from the basic system as a remote control. This is not new technology. We've had remote control machines underground and in the field for many, many years. The next stage up is a remote station. This is a simulated dozer setup, operator setup, where one operator can control a remote dozer. These have been around for a while. You're seeing it takes the operator out of the cab, puts them into a safe environment. Then we move up with a semi-autonomous system where one operator is controlling multiple dozers, and those dozers have some inbuilt smarts, and we'll go through that shortly. The remote station and the semi-autonomous are non-line of sight, so this operator does not have to be on the mine site. They can be wherever you want to be, especially with the internet these days. And these remote station situations, these are not an add-on. These are a factory specified bit of gear. So you can order it from Westrac or your local cat dealer as a factory option. So what is SATS? SATS is a semi-autonomous tractor system. It's a Caterpillar product for the remote operation and automation of our D11 dozers. Currently using them in bulk push scenarios. SATS allows for the semi-autonomous operation of up to 4 dozers by one operator. So one operator sitting anywhere in the world can control four dozers working out in the field, and this is done through a remote trailer or office situation there. And you can see there's only 3 in that example, but they're out in the field working. So why do we have SATS? Of course, you're taking the operator out of the cab. Out of the cab means it's safer. You haven't got an operator being bounced around, shaken, and people were in the earlier presentation inside. You saw some video of a truck driver in a pit. Dozing is a very rough operation for people. You know, body's getting shaken. You can wonder why people slow down a bit in the dozer. If you've been in one on a hard dig, hard ripping, you'd understand. Cost, you're increasing the utilisation and availability. The dozer's not stopping for smoko to get out and have a leak, just to rest because they've had the life shaken out of them. Another one, of course, is productivity. Because the dozer is being controlled by a computer, it's consistent and reliable in terms of its performance. It will do the same thing over and over again, whereas an operator will be driving backwards and forwards, might look out the window, look down at their iPhone, just loses concentration. Obviously a computer doesn't lose concentration. So how does SATS dozing work? We have a dozer, of course. We add some smarts to that dozer, an onboard computer, cameras, high precision GPS, so we know where the dozer is in 3 axes. Additional switching, so the SATS can be turned on and off as you get on and off the dozer. We need a network infrastructure, so the dozer can talk back to the command centre, and a control station. Here's an example of a dozer out in the field. GPS antennas up on the top there, high precision, so we know where we are, XYZ. Some mode lights to tell people around it what the dozer, what mode it's in. Is it in semi-autonomous mode? Is it just in normal operator mode? We have some cameras on board. Cameras allow the operator to see in front, behind, and these days with the 360-degree cameras, we can get a 360-degree simulated view of what's happening around that dozer. And of course some ground level service switching, so as the operator gets off the dozer, he or she can switch it to autonomous mode. little bit of a schematic there, just showing 4 dozers, some repeater stations. Of course, the network infrastructure is driven by site requirements, communication towers, and of course your remote station and servers, all the normal sort of things. And these are all, of course, driven by site requirements. We talk about the control room. There's an example of a truck-mounted control room. So in that situation on a mine site, it could drive around and follow the operation round if you wanted to. The lovely ATCO shed that many of us will have experienced out of mine sites. Again, it can be transportable, or it can be in any location that you need it to be in, on-site or off-site. And of course, a control station itself. The control station mimics a dozer setup. So an operator in that control station, if they've been driving a dozer for years, they've picked them up, put them in a control room. The controls are the same. They're identical controls. So there's no retraining of the operator for that control station. And of course, multiple monitors to give them enough vision around the machine. And our lovely shiny yellow dozer with cameras on it. Operation. So in operation, a dozer operator will take control of a dozer. Using the cameras, he'll position that dozer in the work area and assign it to a task. That task will be then validated while the operator controls it through one pass of that to make sure it's all working, the levels are correct, and then switching over to autonomous mode. Then using the onboard smarts, the dozer will then proceed backwards and forwards doing that bulk push, working within that area, while the operator then can switch over to another machine and set that one up and get that one working. So using that system of assigning a task and then rolling it in, the operator, initially we thought 3 dozers would be enough. We see operators now controlling 4 dozers very effectively. The target there, of course, is having a very safe and highly productive operation. Those dozers, while they're moving backwards and forwards, are productive. They're following a computer algorithm that's been honed and refined to be the most productive it can. Of course, productivity benefits, other than getting the operator out and having them safer, which should always be our first concern, is we have a decreased fatigue. So the operator's not bouncing around, they're in a nice air-conditioned stationary room, more productive. The dozers can work steeper angles, but you don't have that operator perception. Reduced shift change times, you don't have to run an operator out to the dozers and swap them over. He or she gets out of the chair, moves over, and the next operator gets in. So you've got very little shift change time. Immediate operations after blasting. Traditionally, a dozer has to walk out of a blast zone to avoid any risk to the operator. Becomes a commercialised decision how far then you need to move away to keep the dozer safe, because you haven't got an operator there. No operator makes it a lot easier. Dozer high wall cleaning, both the remote and the remote control and the non-line of sight type remote operations as well, you can get right in under the high wall because you don't have an operator in the cab. So there's a huge advantage there to the remote operation of a dozer. A very quick overview. There's obviously a lot that goes into a semi-autonomous tractor system. The CAT command, it's a proven technology with the remote control. It's a stock item from the factory, the remote control machines. It's not an add-on, it's not an aftermarket. It's a factory-supported, dealer-supported system. We have the underlying technologies and have to deliver this system. We've got the runs on the board, and we're refining those as we move forward. So hopefully we'll continue to improve the systems and develop better more productive algorithms. Any questions? I've moved that quickly that you've all got 100% take up. Great.
What's the ballpark figure for the hardware installation on the vehicle?
The hardware installation, I'll take that offline. A lot of the work we do, depending on what model dozer you have, what's already on it, you can buy the dozers at different levels as they come out of the factory. Some require more work, obviously. Some already have terrain if you've got GPS on them. So it's a, yeah, we need to assess what the dozer has on it already. And it's like the network infrastructure, depending on the mine site, depending on what's already there, will affect what as you can imagine, with video you are requiring high capacity network infrastructure to stream multiple cameras across the site. So I'll catch up with you later and we can talk about that one.
Simon, is there any interactions between the dozers pushing to central points? So, for instance, on course or stockpiles or dozer traps or things like that?
With the system, because it's using terrain, you can geofence and there is interaction. They know where they are. They're high precision GPS, so we're talking small differences in accuracy, a 10 centimetre accuracy. So there is that built into the system, so they know where they are with the proximity awareness. So the use of the remote control situation for stockpiles and that sort of thing is a bigger factor. A lot of companies are looking at that because you can take that dozer operator out of the dozer, put him in the control, or she in the control room, and while you still may have a problem with a hang-up, if you don't have an operator in that dozer, if the dozer falls into a hang-up, well, you've got no safety issue in terms of a human safety issue. So it takes that away. So our mine planning has to develop, and one of the earlier presentations was talking about mine planning and autonomy. There's a huge difference. It's not just whack a bit of technology in. You've really got to rethink and go, okay, what can we do now to improve? Where can we gain with our mine planning? With the autonomy systems, some operations that are using the SAT systems have had to rethink how they do their mine planning. You've got to have dirt in front of the dozer. If there's no dirt, there's nothing to push. So, you know, and they like consistent tasks, not do a little bit here, a little bit there. Give them a good task that they can push for hours. That's where you get your big savings. So you need to design around that. Any other questions? No worries. Thank you very much.